So what if I told you that the same basic chemistry principles you probably learned in high school are the secret weapon for cracking a really complex criminal case? Today, we're going to dive into how these simple, fundamental scientific ideas can unlock the secrets hidden at a crime scene. It sounds a little too simple, right? But think about it. The exact same science that separates the grounds from your coffee in the morning can also be used to isolate a tiny, crucial piece of evidence from a messy, contaminated mixture. Let's see just how powerful these basic techniques really are when the stakes are this high. Okay, so our story starts right here. We're at the scene of a suspicious fire that's just ripped through a small warehouse. After the smoke clears, investigators are looking at a complete charred mess. But hidden inside all that chaos are the clues they need to figure out what really went down. At the scene, the forensic team bags up 4 key pieces of evidence. You've got this broken bottle filled with some kind of muddy liquid. There's a mysterious white powder spilled near the door. They also find a document that's almost totally burned, but has some faint ink marks left. And finally, some debris that has that suspicious, distinct smell of an accelerant, like gasoline. Every single one of these is a puzzle, a mixture that needs to be taken apart very, very carefully. So to solve these puzzles, scientists have to turn to their toolkit. And for this particular case, 3 specific tools are going to be absolutely essential: filtration, evaporation, and crystallization. Let's get a quick intro to each one. First up is filtration, and honestly, it's pretty much exactly what it sounds like. It's a physical process that just works like a superfine sieve. The whole idea is to separate solids from a liquid based on nothing more than their size. If a particle is too big to fit through the filter, well, it gets left behind. Super simple, but incredibly effective. Next, we've got evaporation. This technique is all about separating a solid that's been dissolved in a liquid. It works because of something called volatility, basically how easily something turns into a gas. You just gently heat the solution, the liquid turns into vapor, and poof, it's gone, leaving behind the solid that you wanted to get a look at. And finally, crystallization. Now, this technique is a step beyond just separating things. This is all about purification. You take an impure solid, dissolve it in a hot solvent, and then just let it cool down. As it cools, the pure stuff forms these really distinct, clean crystals, leaving all the junk and impurities behind in the liquid. It's a seriously elegant way to get a perfectly pure sample to analyze. All right, so we've got our evidence and we've got our tools. Now it's time for the fun part. Let's put them to work. We're going to go piece by piece and see how this case starts to come together. So our first challenge is that broken glass bottle full of muddy liquid. As it is right now, it's just a dirty mess. We can't really analyze the liquid for any poisons or alcohol or solvents until we get all of that dirt and gunk out of there. So the question is, how do we clean this up? How do we separate the liquid, which could be vital evidence, from all the mud and whatever other contaminants are mixed in there? And right here is where we see the power of that first technique, filtration. It's as simple as pouring the whole mixture through a special filter paper. The solid bits, the dirt, they all get trapped. And what comes through on the other side? A clear liquid. And just like that, we have a clean sample that's ready for a full chemical analysis. Okay, next up, let's turn our attention to that spilled white powder they found near the entrance. I mean, this could be anything. It could be something totally harmless, like salt, or it could be something much more sinister, like a narcotic or even a poison. We've got to identify it, but before we can do that, we have to be sure our sample is 100% pure. And this is the exact question that drives this next step. Street samples of drugs or poisons, they're almost never pure. So to get a positive ID, we absolutely have to isolate the main compound from anything else that it might be mixed with. And that is where crystallization comes into play. On the one hand, you start with this impure, messy mixture, but after you dissolve it and let it slowly cool, you get these beautiful, pure, uniform crystals. And the unique shape of those crystals, that's a huge clue. Plus, the purity of the sample means we can run definitive chemical tests and know for sure what we're dealing with. Now, for our third clue, that partially burnt document. The fire and then the water to put it out have done a real number on this thing. The ink is incredibly faint, you can barely see it, but even a tiny trace amount of that ink can tell us what kind of pen was used, and that could be a critical lead in the case. So the challenge here is totally different. We're not trying to separate a solid from a liquid. We're trying to analyze a substance that's barely even there. The goal here is to concentrate it. And the solution is evaporation. A scientist can use a special solvent to gently lift those trace amounts of ink right off the paper. Then, by carefully evaporating that solvent away, what they're left with is a much more concentrated sample of just the ink residue. And now, that concentrated sample is finally strong enough to be analyzed properly. So, we've now analyzed each major piece of evidence using a very specific technique for each one. Now it's time to step back and look at the big picture. How do all these individual findings add up to tell us what actually happened at that warehouse? And this summary table just lays it all out perfectly. Filtration gave us that clean solvent to test, crystallization purified the white powder, and boom, it was identified as an alcoholic. Evaporation let us concentrate the ink from that document, and for that final piece, the burnt debris, a similar process called distillation was used, and it isolated an accelerant from the ash. The conclusion is now crystal clear. This was no accident. This was arson. You know, what's so incredible about this is that it isn't just a one-off story. These fundamental techniques, they are the absolute workhorses of forensic labs all over the world. I mean, just think about it for a second. Toxicology labs use these exact same methods to find poisons in blood samples. Drug labs completely rely on them to identify illegal substances. Investigators use them to recover microscopic traces of explosives or gunshot residue. These simple, powerful ideas are literally everywhere in forensics. It really makes you think, doesn't it? From a muddy puddle and a pile of ash, basic chemistry revealed a whole story of arson and narcotics. It just goes to show you that sometimes the most powerful answers come from the simplest principles. It kind of leaves you wondering, what other secrets are just out there, waiting for the right scientific tool to bring them into the light?